Hi. Today I'm doing a lightning talk on quantum computers. So I don't pretend to be an expert on this, but I'm just that's just something I'm kind of interested in, electronics and technology. So I'm going to give a talk on this. The other day, I guess now it's almost a month. Ohad kind of mentioned about two slit experiment. So basically, it's when you shoot a small particle through an opening, um, instead of you seeing like one kind of a hole on the back on the screen, you kind of seeing a distribution of the particles. So that kind of indicates a wave, both wave property and particle property for a matter that's in a microscopic world. What does it mean for our computers? As you know, like for computers, we use bits, one and zeros. Basically, it's like we pass electrons through a transistor. You apply a force, and that you stop it, and then there's a zero, and you let it go. It's like a one. So as the transistor shrinks to a smaller and smaller size, you begin to experiment quantum effect, where because you have a wave property, the electrons will you will see like a probability distribution of how electron moves. So in if you have in smaller transistors, you will see like electrons actually tunneling through a barrier. So we reach a limit, um, and because if we want to shrink down, you need to apply quantum laws, and thus quantum computer give us a promise to continue with our technology. So how it works is make use of the principle of superposition. So in quantum world, the particles can exist in different state or at the same time. Um, so basically, it's like when you're trying to determine the momentum and position of a particle, it's a probability distribution. It's a wave function. So it could be here and there, anywhere. So as soon as you take a measurement, this probability distribution collapses into one value. And how that helps us is that in classical bits, you have one zeros, and then for example, if you have 4-bit system, you have 2 to the power of 4. So that's 16 different values, and when you do calculation each time, it will take one of the values. But with quantum bits, it or it, like they can be in any of the 16 values. So that means like you're doing calculation all at the same time, the parallelism, and it's really powerful when you trying to do algorithm like doing searches and factors. So all the setup you make up a kind of setup, and the manipulation of those quantum bits will help you to kind of do everything all together, and you get the result back. But one problem with that is that when you try to measure the results, it's also a wave in kind of a waveform, like a probability distribution. So now you stuck with this, and as soon as you take a measurement, it claps to one value, and that doesn't tell you anything. And what people were dealing with that problem is to trying to make use of another principle within quantum mechanics called entanglement. So it basically kind of describe the correlation between parts of a system. So if you have entangled particles, so when one particle changes states, it's the partner, the entangled partner will also reflect that change, no matter how far apart they were. So it could be end of space, like you make a change here because they are entangled, even though the space between them is very, very large. When you actually look at the other particle, it will reflect instantaneously. So for quantum computers, we use quantum gate to entangle those qubits. So instead of take a measurement of the system, so i.e. the output, we don't want to disturb the system. We look at one of the particles, and so because we know the correlation, ideally we can determine what the state each of the qubits are in, without kind of actually doing a measurement on each of those qubits. So I guess that's a layman term of how the quantum computer works. I think we've made some progress in using a few quantum bits and doing calculation on that, but right now it's still pretty much premature, and I guess in the near future, when we can manipulate more quantum bits, then it will help us do a lot of calculation that classical algorithm cannot do or hard to do. That's my lightning talk. Thank you.
Back, questions?
Right.
I have at least 3 leading questions, but
Okay.
are there any other questions from the crowd first? No. One, is there anyone locally working on this?
D-Wave.
Yeah, D-Wave.
D-Wave, yeah. I had an interview with them before I came to work here.
A
No,
lot of venture capital.
yeah.
Yeah, but I heard their methods like quasi-physics, not really quantum.
Wow, it's kind of judgy.
I don't.
Number 2,
yeah.
a quantum computer is kind of cool and really hard to build. Can you describe what it looks like for us?
So there's different method of making qubit. Like as long as you have like small particle, like you can use electrons or a photon or anything. So what they do is they use magnetic waves or superconductor, some kind to kind of change the, well, let's, for example, electrons, when it's electron has the magnetic field. When you put that into a force field, like they will change spin to a certain direction, and you can use to kind of you can describe it as like having one state or something like that.
I think we just went to the next level. How many people are familiar with the spin of elementary particles?
Yeah.
They're not lying.
Still not lying.
Yeah, and
So the one thing that I read about it was that you have to do most of it at as close to absolute zero as possible.
right,
So your entire computer has to be inside a super cold
that's
device.
that's
Absolute
correct.
zero.
Mine is 273.
3.15.
Yeah.
So it's a
No, no,
temperature.
it's zero. It's 0 Kelvin. It's cold.
It's really cold. And
It's when.
Your education is showing,
and
Randy.
it's a
Yeah.
value
Not
that
all of us are
Molecular
from tech
motions.
backgrounds.
you can infinitely approach that value, but you never can get that exact value.
The coldest I ever got anything was 1.8 Kelvin.
That's cold.
Yeah.
That's
And so my last question is, should Paul be drooling because his next best gaming computer is on the way?
probably not.
It's a ways off.
Well, no, and
Because
possibly never.
Quantum computers is only good for certain calculations where you want to do things in parallel. So in searches, in classic algorithm, you look for each pass, right? And then you search. If you want to find the most viable pass, you have to you have to calculate all the passes before you determine that. So the quantum computer does everything in parallel. So ideally, if it's n pass, you have a square root of n, and that makes things really fast. But in other calculations,
Do you think that will help?
So
but in
Paul's
other-
Googling will get faster.
yeah,
Yeah.
I guess, and your security, because your encryption is depend on
Breaking security.
yeah.
All right. Any other questions? Paul, is that a question?
Nope. Sorry.
All right. Thank you, Richard.